In this learning activity, I want to show you the process of modeling a transportation problem. So when I refer to a transportation problem, basically I'm referring to the situation where we have various sources, perhaps a manufacturing plant, and various destinations, perhaps distribution centers or retail stores or something like that. So ultimately we have a plan for how many products perhaps that we're manufacturing from those facilities and shipping them to our distribution centers. So let's begin by discussing the learning activity by going through the problem background. In this particular problem, we have a pharmaceutical company that manufactures and distributes their prescription drugs to various distribution centers across the United States. So the drug company has manufacturing facilities in Los Angeles, Atlanta, and New York City. We're given some extra information here that the Los Angeles plant can produce up to 15,000 pounds of drugs per month. Atlanta can produce up to 12,000. New York up to 20,000 per month. The drug company has distribution centers which are just labeled as East, Midwest, South, and West regions of the United States. Each month, the company must develop a transportation schedule to fulfill this order. So basically, these regions are requesting amounts of drugs. So for example, the East region must receive at least 9,000. So it could be that the East region put in a request for maybe a schedule, I should say, for more than 9,000, and that would be okay. And there would be a problem, let's just say for an example, if we're actually sending them less than their minimum desired amount. So the mid region must receive at least 6,000, south at 6,000, and the west region, they are requesting 14,000. So wrap your mind around this particular problem for a second. Essentially, think of this problem as you are responsible for developing a transportation schedule where you're deciding how many pounds are being manufactured at the facilities, and then you decide where they are shipped to. So Los Angeles could ship to all of the regions, Atlanta can ship to all the regions, and New York can ship to all regions. So let's continue some of the problem background. The manufacturing cost per pound is provided in the table below. So regardless of where we're going to send these, we have a fixed cost of manufacturing these drugs. And for example, Los Angeles is $2, New York $1.80. The shipping cost, however, is going to depend on where the manufacturing facility is and where they're shipping to. So we have a table provided that if we are manufacturing in Los Angeles and we need to actually send that all the way to the East Coast, we're going to have a pretty high shipping cost per pound at $5. But, for example, if we're in Los Angeles and we're shipping to the West, we will have a cheaper or less expensive shipping cost of $2.20. So the table provided below represents all of the shipping costs. So whatever schedule or whatever order, I'll use those interchangeably, whatever schedule we come up with, we'll need this table to calculate the total cost based on our order. So the task at hand is to develop a spreadsheet model that will calculate the total cost of manufacturing and transporting any given pharmaceutical order. So based on any size, based on pounds that might be requested. The spreadsheet must be designed in such a way that orders can be easily updated. So for example, I recommend that we build a spreadsheet around this tabular format. So we have a schedule below where we have the manufacturing facilities on the left, Los Angeles, Atlanta, New York, and along the column headers, we have all the regions, East, Midwest, South, and West. So inside this table, this represents the schedule. So if right now I am sending out, let's say, 1,500 parts from Los Angeles to the Midwest region. I'm then also sending 7,500 pounds from Los Angeles to the West region. Likewise, I'm sending 3,000 pounds from Atlanta to the Midwest, 7,000 pounds from Atlanta to the South region, 3,000 pounds from Atlanta to the West, and then 2 more transactions, New York to the East, 14,000 pounds, and New York to the Midwest, which is a 3,000 pound order. The rest are 0, meaning there's no transaction. Okay, determine how many total units will be sent from each manufacturing facility. So basically what I want you to do is to calculate the total pounds being sent from those 3 manufacturing facilities. And I want to compare this in the spreadsheet to the capacity of each of those facilities. And the reason why we want to do this is because we actually want to check to see if we have generated a schedule which is causing one of our plants to work overtime or going over capacity. So if this is a situation where one of the plants is actually scheduled to go over capacity, we want some sort of cell in the spreadsheet to indicate a yes or Y, if you will, in the spreadsheet to suggest that it's over capacity. If it's not, we're just going to simply put an N. And anytime we do have a Y, which indicates a yes, I want you to use some conditional formatting to basically shade the cell red so instantaneously we know there's a problem. Likewise, I want you to do the same thing for the orders received by the regions. So calculate the sum of the pounds being sent to the regions and compare this to their minimum order demand. If we are underfilling those orders, we should indicate somewhere in our spreadsheet a Y for yes and an N for no. So if we have not, I should say, underfilled that order, let's put a yes. If not, let's put a no. And again, if we have a Y, let's display that with conditional formatting, cell in red fill. So again, just to kind of describe this problem situation one more time, we assume that this spreadsheet is for some sort of internal use, that we have this master scheduler, if you will. We know the capacities and the minimum order demands of all of our regions, and we're using this spreadsheet to generate a schedule that we can actually use to make sure there's no problems of overcapacity and there's no problems with under-fulfilling orders. So I have provided you a schedule. Expect some problems because I basically want you to visually see when there are problems. So the idea is that a master scheduler could actually look at the spreadsheet and say, you know what, we've got a problem, let's change that schedule around a little bit until we have a schedule or an order that makes sense, that we're making everybody happy, fulfilling those minimum orders. Again, it's okay if we overfill, but we don't want to underfill. So again, we will have some errors so we can see those conditional formats, and I still want you to calculate the total cost based on the order that I gave in a previous slide. So we're going to go ahead and start this learning activity, but I really would challenge you to spend some time developing this before even watching the video. So take all the information that you have in this learning activity and try to develop it on your own, because some of the benefit of doing that is to actually think about how you're arranging your data, arranging it where it's logical in nature and we have things that are grouped together physically together, and you know, it's often easy to be told, I guess, what the optimal layout or what a good layout of a spreadsheet would be, but it is also useful for you to think about that on yourself. So I'm going to go ahead and start the learning activity. Okay, when we open up the starting file, what we'll see is 3 tables. We have the manufacturing cost, we have the shipping cost, And then we have the current order, which I gave you, which again, there might be some problems, and we want to display those problems with conditional formatting and some of the other things. So the first thing I would recommend is getting a table that represents the total cost. So in this situation, we have a manufacturing cost and then the shipping cost. So what I would recommend is actually combining both of these tables into one table. That is basically all calculations. So what I'm going to do here is insert some rows. And I'm going to copy this table because my table that I'm going to create is going to be of the exact same size and shape. So I want all that formatting there, which will save some time. So what I'm going to do here, instead of calling this a shipping cost per pound table, I'm going to call this total cost per pound. And we need to calculate these values here. So with that said, it's a simple summation of the location of the manufacturing facility, let's say in this case, $2 per pound, plus the individual shipping cost. So the only thing we have to do here is to lock the row, or I should say the column, because as we fill this to the right, we don't want that reference location to move. So let's go ahead and just lock that column, hit enter, fill this formula right and down, which you're going to notice that the table has basically been copied here, $2, $1, 10 cents, $1.80, all the way across the table. So when we add the individual shipping cost, we already have this manufacturing cost built in. So I will go back to the formula and simply add the value in the table in the respective location. So let's hit enter. Now we have $7. We're going to fill the formula right, fill it down, and now we have the total cost. So that's going to make it a lot easier for us to calculate a total cost because we actually do have an order here given. So one of the things that we were given in the problem is that we were given certain capacities, and I'm going to list those capacities here. And you might have to refer back to the notes, but the capacity for Los Angeles was 15,000. Atlanta was 12,000. And New York was 20,000. Okay, and I'm leaving some space here because there's some logic that I want to develop inside this spreadsheet. But right now I'm just kind of entering what we know. Okay, again, I'm going to put the minimum demand here, just like I did with capacity. And I'm going to spend a little bit of time just explaining a little bit about the table as I go, if it's not clear by now. So after I do this, let's go ahead and put the minimum demand of 9,000, 6,000, 6,000 for south, and 14,000 for the west. Okay, so you might be asking, well, why did I arrange this table like this? Why do I have capacity along the column G here and minimum demand along the row? Well, what this table is actually referring to is the exact shipping schedule. So if I do say Los Angeles East 0, that means there's 0 units being produced by Los Angeles that is being shipped to East. However, Los Angeles is actually shipping a total of 12,000 units, the 1,500 plus the 10,500 units in total. So I left a space here on purpose because we have a schedule to be sent value here. So scheduled to be sent will be a sum of everything along these columns for Los Angeles. So we have the 12,000. So Los Angeles currently is actually well, it looks like I do have a typo here. This shouldn't be 1,500, it should be 15,000. So I'm going to put an extra 0 there. Right now, it does appear that Los Angeles is under capacity, so it's okay. If we need to schedule more units to be made and shipped from Los Angeles, that's okay. We've got some capacity slack there. The next one, let's go ahead and fill this formula down. It does appear that we're over. We have generated a schedule here that will cause Atlanta to be over the capacity. So they have 12,000 capacity, but they are being asked to send 13,000 capacity. So as a scheduler, we would look at this and try to make a good decision of where we need to reduce 1,000 pounds off of this schedule and basically get it from one of our other manufacturing facilities. Okay, so anyway, we have a very similar situation here. We have a scheduled to receive. Okay, so scheduled to receive would be simply a sum of all the values. So if we're looking at East is going to get 14,000 units from New York and 0 from the other two. So the total the East is going to get is 14,000. If we fill this to the right, looks like we are getting pounds from Los Angeles, Atlanta, and New York. So we have altogether 7,500. And we have, 7,000 from Atlanta to the south. That's the only source. And we have 2 sources from the west. We have Los Angeles and Atlanta fulfilling the order request for the west region. Okay, so let's do some formatting with borders. Okay, so we have just about everything that we need so far. I did ask for an indication of when we are over capacity and when we are underfilling. So I'm going to put this here because I think it's logically related to both of these columns. So we have the header over capacity. And usually what I do is I put a Y or an N for no, and this sort of indicates to me that it's a logical calculation. Overcapacity, yes, no. So this will be an if statement. So if we have sent or we're scheduled to send out more, so if we're sending out more than our capacity is, we have a situation where we're over capacity. Otherwise, it's going to be a no. Okay, so we have a no here. We have a yes here. Let's evaluate this logic. So if what we have scheduled is 13,000, it's greater than our capacity of 12. So in that situation, I want to display yes. Finally, we have a no here because 17,000 is actually less than 20,000, so we have nothing to worry about. So let's do a little formatting here. I'm going to actually center these values, make it a little bit more visually appealing, I guess, at least in my eyes. And I'm going to do the same thing down here. I'm going to say underfilled, yes, no. And I'm going to use a similar format here, borders here, and essentially write the conditional statement. If what they have being sent, so we are looking for situations where it is underfilled. So if the 14,000 here is less than the 9, that's going to be a false condition. But if that was in fact true, we want to indicate that that's a yes. So we'll go through some of these examples. If that is not true, let's indicate the false condition, so we're going to put a no. So what is this basically telling us? Well, it's saying, well, we have a minimum demand of 9,000 and we're scheduled to receive 14. So we are actually okay. We're sending the minimum, we're actually going above the minimum order, so we're not underfilling that order. We're at a no state. If we fill this to the right, we have a no state here. 75 is greater than 6, so we're okay. The only situation where we do run into an underfulfillment is the issue with we're sending 13,500 to the west, and the west actually wanted 14,000. So again, in this type of spreadsheet, you might be a scheduler and you might actually be responsible for changing these numbers so we actually are receiving and sending out correct values. Okay, the one last thing, or I guess there's two things. We have to calculate the total cost and we have to indicate Y's with a conditional format. So I'm going to start here with this one, and I'm going to say conditional format, new rule, format only cells that only contain a specific text containing, and I'm just going to refer it to a Y for yes. Let's format that. Fill this as red. Hit OK. Hit OK here. This is a no, so I wouldn't expect that to be highlighted. I'm going to copy the format with a paint formatter and go paint that format here. We do have the red here. Let's copy that with a format painter and paint that format here. So anytime we have a situation where we have a Y, this is going to light up. So again, if I was a scheduler, I would look at my capacity and say, hey, we're over 1,000 units here. I would then alter where we're actually manufacturing and sending our units here. So maybe I would quickly look at these two and say, well, the Midwest is getting 500, it looks like 1,500 more units than what they really need. Maybe I'll just drop this down to 2,000. And then that would take care of my capacity problem for Atlanta. And then I might come up with a strategy to go ahead and fix this capacity. So I needed 500 more. Maybe I would, since I would then take a look at capacity here and say, okay, well, I've got a little capacity in Los Angeles. Maybe I will send them 500 more units, which would raise this to 11,000. And then I would have no problems at all. Okay, I'm actually going to undo those two changes so we have the original table, which is here, and finalize this learning activity with a calculation of total cost. So we have total cost. Let's go ahead and apply our format. Okay, total cost, since we actually combine these tables, we can do this in one simple formula. We can calculate the total cost by a simple sum product, the sum product of the total cost per pound, comma, the order. And that's it. So we have a total cost in this situation of $176,350. So that's what it's going to cost us to not only manufacture, but to distribute our products. Now, for those of you who have used Excel a lot, this is actually sort of going above the example, but I wanted to show you a feature in Excel that is really powerful and really utilized for optimization. So we can definitely manually change these numbers until we don't have any issues, but it might not be at the minimum cost schedule. So what I actually want to show you is quickly a technique, and this is just to give you some additional exposure to the power of Microsoft Excel. I want to go to data, and there's a thing called Solver, and Solver is an optimization tool, and if you don't have it added, that's okay. Again, this is just to expose you to some additional features. Let's go to Solver, and what I'm going to try to do is calculate the optimal schedule without manually trying anything. I'm going to say, hey Excel, give me the best order mix, if you will, for this particular situation. So I want to minimize my cost. So the objective cell will be my total cost that I have formulated. I want to minimize that. I don't want to maximize total cost, of course, by changing my decision cells, which are here, which would be the plan. I need a few constraints. The being sent has to be less than or equal to the capacity. So I can't send more than what I have capacity for. The total received can be greater than or equal to the minimum demand. Then I'm going to add one more constraint, which says that whatever I send, we send in integer pounds, meaning I don't necessarily send a bag or so many pills that is a fraction of a pound. And that, of course, could be debated if I do or not. But let's say our drugs are packaged in a way that it's in per pound samples. So let's hit OK. I'm going to leave all of these constraints and all these options where they are. And hit OK. It says solver has found a solution. All constraints are optimally satisfied. Let's hit OK. And now just briefly look at the schedule. If we remember right, the schedule was 176,000, and solver was able to tell me that I could save, well, let's just see, this was 176,350. I could actually save almost $40,000 in this transportation problem. So again, this is beyond the scope of this particular learning activity, but I wanted to give you a glimpse of the power, which is really nice and actually can be extended to much more challenging problems. But this is actually very useful in this type of field.